Stanley Cohen is the other scientist in the discovery. Also aged 69, Cohen remains a genetics and medicine professor at Stanford University. In his eponymous laboratory, more than 10 researchers conduct the most advanced biotechnology research.
What underlies the success of science is the ideas for creative experiments that address important and meaningful scientific questions.
Cohen and Boyer met in 1972 when they both attended a scientific conference in Hawaii. There, the academics explained their research projects. Boyer was studying the state of DNA after being cut by certain enzymes. He found the open ends from the cuts can link up with other similar genetic fragments. Cohen was specializing in research into plasmids, the DNA in bacteria that's shaped like a small ring and has the ability to self-replicate.
Well, I suggested to Herb that we collaborate, and I told him what I had in mind. And he said, well, you know, he was thinking of similar types of experiments. So it was a perfect match.
He didn't have the enzymes to do it, and I didn't have his little plasmid. So it was a perfect marriage.
Cohen and Boyer linked the DNA of a frog with a plasmid and put it back inside bacteria. They found when bacterial cells multiplied, the new DNA also self-replicated. This breakthrough is called cloning. It enabled the mass production of medicines such as insulin and growth hormones.
The other application is to be able to think about gene therapy. The same thing, by taking a piece of DNA from one organism and put it to another animal, so that we have the so-called biotechnology, genetic engineering, so we can improve the quality of crops, improve the quality of stocks, and all that. It's all as a result of this ability to manipulate, to clone DNA.
Genetic engineering benefits mankind with innovations in healing diseases and making drugs, but it also raised the controversial possibility of cloning animals or even humans.
What we were doing was trying to find out why there had been such a big increase in lung cancer.
And so, with a good cup of tea, begins Sir Richard Dahl's story about a study that was to eventually change smoking habits around the world. As a young medical epidemiologist, Sir Richard worked here at London's University College Medical School. It was the mid-40s, and lung cancer across England was spreading fast. Doctors blamed it on car exhaust and road tarring. No one thought of cigarettes.
It was very difficult to believe it was, of course, because everybody did it. It was such a common thing.
You smoked?
I smoked, yes, I did. I gave up halfway through the study when the results began to become so clear.
Results after questioning 700 patients diagnosed with lung cancer in hospital, and some important follow-up detective work.
And one of my jobs was to go round afterwards and look at the discharge notes of each patient and see what disease they actually had. And what I found was that if the person had been recorded as a non-smoker, the diagnosis of lung cancer was never right. It turned out to be something else. Whereas if it was a heavy smoker, it was very frequently right, nearly always right.
Sir Richard and his colleagues published a paper of their findings, linking smoking with lung cancer, but response was underwhelming.
It couldn't have had less attention paid to it. Very few people took it seriously, and even the Cancer Advisory Committee to the Department of Health advised the department not to do anything about it because it said it isn't really proved. It frightened people. You shouldn't do anything about it.
The results weren't believed, and neither was the way the information had been gathered. Sir Richard's methods, cohort and case control studies, standard now, were a revolution in medical research at the time.
You were really doing the uphill battle, weren't you?
Yes, yes. It was to get this technique established as recognized as a way of proving a cause of disease.
So this is
Yes.
this is the route to the office every morning.
That's right, yes.
That's quite good, isn't it? It's like a 5-minute walk.
It's very nice indeed, yes. I've always been privileged living in Oxford ever since I've been here. I've lived in 3 different houses, or at 4 now, and I've always been within walking distance.
Sir Richard and his colleagues set out on another study right away, this time questioning 2/3 of Britain's physicians, 40,000 male doctors, surveying their smoking habits and those who went on to develop lung cancer. 3 years later, they had a direct link. That was 1954, but they still had a long wait before the British government, media, public, and then the world woke up and noticed.
It wasn't until 1957, that's 7 years after our first report, the government formally asked the Medical Research Council for its opinion on what our findings meant. Well, here's the beginning of a new article, MC, if you wouldn't mind having a go at the first draft of it. And in 1957, the Medical Research Council said they mean that cigarette smoking is responsible for the great majority of lung cancers.
Sir Richard Dall arrived here at Oxford in 1969 into the highly regarded position of Regius Professor of Medicine. Warden here at Green College, he directed his own medical research unit while publishing breakthrough studies on subjects ranging from asbestos to peptic ulcers and the pill. But it was his groundbreaking work on smoking and cancer that continues to impact the minds and the lives of millions around the world.
Richard Dall told us how to avoid death in middle age. 30 years ago in Britain, half of all the deaths in middle age were caused by smoking. Since then, most of the smokers in Britain have given up, and we've got the best decrease in tobacco deaths in the world. Richard Dall's work has avoided millions of deaths.
In 1954, the year Sir Richard's second study was published, 80% of British adults smoked. Today, it's just a third that, 26%. Richard Petos worked alongside Sir Richard for 35 years. Together, the two enjoyed a glorious moment this past summer with the publication of the longest and the largest work on smoking ever. A landmark 50-year study, following the original group, some 40,000 male doctors, surveyed back in the early 50s to now, with some rather surprising results. Number 1, long-term smokers die an average 10 years earlier than non-smokers. Number 2, giving up works really well. Stop at 60, add an extra 3 years to your life. Kick the habit at 50, and you get 6 more years of life. And before that, well, you're just about turning back the clock completely.
If you stop at 30, even if you stop at 40, you avoid most of the risk of getting killed by it. It's extraordinary the way the body can make good the damage. Stopping just works ridiculously well. Those are the two main conclusions. The risks are bigger than people thought, and stopping works better than people thought.
Anybody who's interested in history will be interested in Richard's life. And really, for the last 50 years, Richard Dall has been the world's leading epidemiologist. And his contribution to public health medicine, just to make people healthier, to understand how to avoid cancer, the big fear of the 20th century, for that alone, one would like to see what were the things that drove Richard on to work so hard and to be so dedicated to such a great humanitarian task.
Conrad Keating, former BBC journalist, is writing a book about Sir Richard's life, from his birth in 1912 to his years fighting in World War II and his dedication to socialized medicine in England. Sir Richard's asked Conrad to wait to publish the book until after he's passed away, giving the author full freedom.
Richard, hello.
Sir Richard, knighted for his contribution to medicine in 1971, spent 30 years in the Communist Party. He met the love of his life, Joan, and survived her death 3 years ago. But marrying her to begin with was a determined battle.
Joan was married to Hugh Faulkner, another iconic figure in left-wing London medicine, and they had a son. And I think it was very difficult, caused a massive split in London left-wing medicine. And it was true, I know Richard used to get phone calls from King Street, from the headquarters of the Communist Party of Great Britain, telling him to break off the love affair with Joan Dole, that this was wrecking everything that communist doctors were trying to do. So he had to fight for her love, and I would say it was perhaps the most rewarding fight of his career.
It's when I got an honorary degree at Harvard, and I was on the platform, and my wife was in the audience, and after I was presented with the honorary degree, I turned around and I blew her a kiss, and I had no idea the photographer was focused on me at the time, and he just caught me blowing a kiss to my wife, which I thought was rather nice.
Yeah, beautiful.
So I'm rather fond of that picture.
Always a fighter for his beliefs, Sir Richard's work has been recognized worldwide. He's received honorary degrees from 15 universities, co-written a book on cancer, and over 400 papers spanning a wide array of issues. He's uncovered evidence showing alcohol can increase the risk of breast cancer in women, and people with gastric ulcers shouldn't be limited to a bland diet. He's testified in court battles with Big Tobacco, spent weeks on the witness stand arguing the merits of fluoride in water. He's still working today, investigating the effects of radon in houses, which he says are more dangerous if you smoke. And he's won several awards, but he's modest about that.
How many awards have you won?
About 20.
In fact, it's about 32. But none are on display. They're humbly hidden from view.
What's this? American College of Physicians. American Cancer Society. And one or two are gold medals, like the title, but I don't keep them here, I keep them locked up. I can't show you. Royal Society of Medicine. I've just been so lucky in life.
And it was another sort of luck that landed Sir Richard in medicine to begin with. His intention was to study maths. He went to Cambridge to test for it.
It was a 4-day exam, and on the night of the third day, some, quote, friends, unquote, who'd gone up the year before, took me out to dinner in Trinity College, where they gave me 3 pints of Audit Ale, which is 8% alcohol. Well, the next day, my paper was not very good.
And so he wasn't offered the full scholarship he was expecting.
And I was so cross, I said, Father, I won't go to Cambridge and read mathematics. I'll do medicine as you wanted me to do instead, and I'll go to London to study medicine. And that was how I came to study medicine.
Can thank a hangover.
That's right. Best 3 pints of beer I ever drank in my life.
Well, let's have a toast,
Yes.
shall we?
Okay, yes.
To your winning the Shaw Award.
Thank you indeed.
Congratulations.
Something indeed.
The Shaw is Sir Richard's 33rd award, and with the Shaw Award comes $1 million American in prize money. Sir Richard will give a portion of that to each of his 2 children and donate a good chunk to his beloved Green College Observatory for building renovations.
It's here. This is the new Dole building.
Yes, the whole of this building.
By next summer, the Dole Building will house Oxford University's new Epidemiological Research and Clinical Trials Unit. But it's miles from Sir Richard's home, so that's when, he says, he'll finally retire.
Did you ever think you'd have a building in a hospital named after you?
No, I never did.
Underscoring again the good doctor's contribution to public health and a life in service.
What do you think you've given the world?
I haven't given the world anything like as much as the world's given me. I hope I've given the world the idea that life is worth living.
University of California, San Francisco. West Wing 9th floor is one of the most sophisticated biotechnology labs in America. Researchers here are exploring one of the hottest fields in recent years, gene therapy. They inject genes into the heart of mice to treat heart disease. Initial results are promising.
In animal experiment, this treatment...
Heading this research team is a scientist from Hong Kong, Can Yut Wai.
我讀嗰時我都諗唔到會做研究工作嘅。我喺香港畢業嘅好多人，即係我啲同班嘅，個個都係出嚟做醫生嘅。
Can began his career as a hematologist. 4 decades ago in Montreal, a newborn baby with thalassemia brought about a change in his career and his life.
At that time, very little was known about the disease, so I thought that perhaps, I would like to do research and investigate how this disease come about.
The Human Genome Project is now completed. The sequences of the 3 billion DNA in the human body is no longer a mystery. But to figure out what trait each DNA sequence is encoded to control is still a formidable task today, let alone 30 years ago. In 1975, Can discovered that thalassemia was caused by the absence of one particular gene, the first time a disease had been defined at the DNA level. The following year, he became the first person to diagnose a disease using DNA when he checked for thalassemia in a fetus by examining DNA extracted from amniotic fluid.
I think it's really to...
Judy Chang has collaborated with Can for over 20 years. She worked under him on thalassemia research.
He always show very enthusiastic about your work. You don't get bored working in the lab.
Maybe you should ask her when I'm not around, so see what she really think.
Very seldom that he's not around.
Is that right?
Judy finds Can a motivating leader, but he's a man of few praises.
我父親好少讚我哋，係嘛？如果做唔好就有得鬧，做得好就應該嘅。
即係你秉承住你爸爸呢一個咁嘅性情，就做得好係應該嘅。
係冇錯。
做唔好就鬧啦。
係啦，冇錯。
咁你鬧唔鬧你啲 assistant 嘅咧？
都唔使點鬧嘅，俾面色佢睇就得㗎啦。
他說他不用罵你們，就是給他的 facial expression。
如果他不跟你講話，那你就知道不對。
Can Yut Wai was born to a prominent family in Hong Kong. His father, Can Tong Po, was one of the founders of the Bank of East Asia. His eldest brother, Can Yut Keung, was a former senior ex-official member of the Executive Council. Can Yut Wai is the only one of 14 siblings to study medicine.
My father, he decided that his youngest son should go into medical school. In those days, of course, you do exactly what your father tells you to do.
And you were very obedient.
Yeah, we have to be, or we won't survive.
Can's greatest contribution to human genetics is his discovery of DNA polymorphism in 1978. At the time, Can was studying sickle cell anemia. He found certain enzymes cut certain DNA sequences at particular spots. When the enzyme reads the DNA sequence CTGAGG, which is found in normal people, it cuts the DNA. But in sickle cell anemia patients, there's a mutation. The nucleotide A is replaced by a T. The enzyme doesn't cut this sequence, and the DNA retains its length. Just by gauging the length of the sequence, doctors can tell if a person has the disease without looking for the actual sickle cell anemia gene. This phenomenon is now known as DNA polymorphism. By looking for polymorphic variations in DNA sequences, researchers can detect hereditary diseases in patients.
Now, somebody would use an analogy of finding something else to mark the region. We know that the 7-Eleven, the convenience store, is quite well distributed in any city. If you want to find a certain house, if it can tell you that it is near a certain 7-Eleven store, then you can actually go find the store, and then you know that within 1 mile distance, you will have this particular house.
Over the years, Kan has received numerous awards for his groundbreaking work in genetics. In 1981, he became the first Chinese Fellow of the Royal Society of London. In 1991, he won America's most prestigious medical prize, the Albert Lasker Award. This year, he received the Shaw Prize in the Life Science and Medicine category.
He is really the father of modern human genetics. Whereas I myself really benefit from his contribution. The way I found the gene for cystic fibrosis really literally follow the concept, follow his original observation.
我就覺得原來全世界好多聰明嘅人，係咪啊？有啲人聰明過我好多嘅，但係我啲成就就高過佢，就係因為我啱啱有啲幸運。
Kan's scientific research is meticulous, leaving no room for error. But he can be loose in other matters. When his grandchild was born, his friends wanted to see a photo of the child.
我出去 internet 攞個 BB 相印咗出嚟話呢個係我孫啊，但係等個 question mark 喺度因為個 BB 都咁上下樣㗎嘛，你揀個多係揀個多啲頭髮或者少啲頭髮嘅啫。咁你揀呢個多頭髮嘅少頭髮？我都唔記得咗，我都唔知佢有冇頭髮，不過係揾個中挺㗎啦。
Napa Valley, California. Every weekend, Kan and his wife would stay here.
There was no sun yesterday.
Such weekend breaks, however, was rare when Kan was younger. His wife describes him as a workaholic, laboring deep into the night and merging private life with work. She says soon after their second daughter was born, Kan extracted blood from her for research.
You can't get many women who are going to give blood that way, or put their child up for a blood sample at that young an age. And it was very difficult. They had to try to get a vein in the head when she was about a month old.
So what was your feeling?
That's fine. No problem.
Anything for research,
Will be more
but there's nothing, just drawing some blood from a baby, nothing.
Not from the jugular, dear.
Oh, no, they do that. That's one.
I know it, but it's awful. Anyway.
So you think the research work is the most important thing in your life?
No. My wife is more important.
Oh, prove it.
Wow, so many candles.
Yeah,
older than I am. 6-year-old, 7-year-old.
Where's the fire extinguisher?
Uh-oh.
Happy birthday, dear Gong Gong.
Kan Yutwai is now 68. After almost half a century as a scientist, he intends to continue with his research and hopefully come up with more breakthroughs.
用嗰個基因治療啦，而家仲要好多工作先至做到，希望將來就做到可以幫助啲病人啦。
Biotechnology is a fast-developing industry. Along this one street in San Francisco alone are about a dozen such companies, including the world's first biotechnology firm. This firm was co-founded by entrepreneur Robert Swanson and scientist Herbert Boyer. Their statues still adorn the front of the building. They set up this company 30 years ago based on an important discovery by Boyer and another scientist. Boyer was an obscure scientist until this discovery that DNA cloning technology can be used to mass-produce medicine. It made him famous and rich.
Oh, it changed my life because after these discoveries in the early 70s, we did get quite a lot of attention from television, magazines, and newspapers, and so on and so forth.
Boyer, aged 69, now lives in this mansion in San Diego. He was a biology professor at the University of California, San Francisco, retiring more than 10 years ago. He says the scenic view reminds him of his days back in the laboratory.
For me, science is a young man's engagement. It takes a lot of energy, and I used to work 14 hours a day, sometimes more, Saturday, Sunday. It was almost an obsession.
Cohen and Boyer met in 1972 when they both attended a scientific conference in Hawaii. There, the academics explained their research projects. Boyer was studying the state of DNA after being cut by certain enzymes. He found the open ends from the cuts can link up with other similar genetic fragments. Cohen was specializing in research into plasmids, the DNA in bacteria that's shaped like a small ring and has the ability to self-replicate.
Well, I suggested to Herb that we collaborate, and I told him what I had in mind. And he said, well, you know, he was thinking of similar types of experiments. So it was a perfect match.
He didn't have the enzymes to do it, and I didn't have his little plasmid. So it was a perfect marriage.
Cohen and Boyer linked the DNA of a frog with a plasmid and put it back inside bacteria. They found when bacterial cells multiplied, the new DNA also self-replicated. This breakthrough is called cloning. It enabled the mass production of medicines such as insulin and growth hormones.
The other application is to be able to think about gene therapy. The same thing, by taking a piece of DNA from one organism and put it to another animal, so that we have the so-called biotechnology, genetic engineering, so we can improve the quality of crops, improve the quality of stocks, and all that. It's all as a result of this ability to manipulate, to clone DNA.
Genetic engineering benefits mankind with innovations in healing diseases and making drugs, but it also raised the controversial possibility of cloning animals or even humans. Scientists in this research field have been killed or maimed. Boyer has received threatening letters.
Well, they would just say that you better be careful when you're walking out of your laboratory. Someone may be waiting to shoot you or threaten the family. I never worried about it too much. I mean, I paid attention, and there were some precautions that I would take. I was more concerned about the family than myself.